All right, so welcome to lesson number 3, learning objective 1-3, which is all about trend lines. So the goal for this one is to learn how to use a ruler to draw a best fit trend line and calculate the slope by identifying 2 points on the line that are not data points. Keywords here. So we're learning how to do a best fit trend line. We're learning how to calculate the slope. And we're doing it by identifying points on the line that are not data points. All right, so when drawing a best fit trend line, what we're doing is we're making a straight line that shows the pattern in your data. A good rule of thumb here is that a good trend line will have as many points above the line as it does below the line. And so, one way to show this is if we have a ruler. Here's my little ruler right here. I'm going to take it and drag it over here. And I'm going to line it up with the 0 over there, the origin. And I'm going to try to move it around until I have as many points above the line as below it. So it's going to look something like that. And you'll see, for example, that I have like 1 point right here that's above, I have 1 point right here that's above, 1 right there that's above. And these guys are pretty close to the line. It's not exactly even. I've got about 3 above and 2 below. It's an odd number. That's going to happen. All right, so we're trying to get close. All right. So my trend line, if I was going to go ahead and draw it on here, and this is a little tip, by the way, if you hold your finger when you're drawing with the pencil on Notability, it'll make a straight line. Like you hold it down and then move it, it'll only give you straight lines. So I'm going to draw my straight line kind of like that. There's my trend line. Next thing we have to do, once we've drawn our trend line, we now need to identify points so that we can calculate the slope. So in order to find the slope, what you need is 2 points. And those 2 points need to be on the line. What do I mean by that? Well, I cannot select, just to use an example, I cannot select this point, because that point's not on the line. And even though it's at a nice intersection of a grid right here, see how those lines intersect? I can't use that point because that's also not on the line. I need to use points that are on the line. The other thing I need to know is that they cannot be data points. So in other words, and I'm going to draw on this picture now for a second, and I want you to draw on there as well. Whenever I draw, I like to pick a pencil that is in this middle row. So if I want to draw something big, I'll pick that big one. If I want to draw something smaller, I'll pick this one over here, just as a rule for Notability. And so I'm going to cross these out. You cannot use these data points to find the slope because they're almost never actually on the trend line. So just a rule of thumb, do not use the data points. I'm now going to switch to a smaller pencil, and I'm going to write that in. I'm going to say, don't use data points. Okay. So what am I going to use? Well, there's a little hint up here that says, look for spots where the line intersects the corners of the grid line. So I'm going to actually go over here, start down here. I'm going to zoom up. And I'm going to find, see this little spot that I circled with 0? That spot right there is basically a place where the line intersects the blue grid line in the background of my drawing. Okay, so that's a good point to choose. And then as I zoom up, it's kind of missing the grid lines, it's kind of missing the intersections. But I get up here and I go, oh look, here's another spot where the grid line intersects with the trend line. And so those are the points that I'm going to select. The value of those points are 340. So this one right here is at 3 and 40. And then The other one is 9, 120. So it's right here at like 9 and right here at 120. Okay? Once I have those points, I can go ahead and use them to calculate the slope. Okay, so when we calculate the slope, we do that by using a formula known as rise over run. And we mean things by that. I'm going to go ahead and start highlighting a little bit. Remember that our x-axis is the independent variable, and we've been doing independent in blue. So rise means the change, sorry, x values. Run means the change in the x values. And rise, which would be our y value, the dependent variable, means the change in the y values. So run and rise. Looking at our data here, the y values are right here, 40 and 120. The x values are 3 and 9. So when I'm setting up my equation, I'm going to have rise, which is green, up here on the top. The change in the y value is 120 minus 40, up here on the top, which is 80. The run, on the other hand, is down here on the bottom, which is 9 minus 3, or 6. Now, a lot of times in math, I know you guys leave your slopes as fractions, but in physics, we usually like to actually do the division and come up with an answer, which in this case is going to be 13.3. One thing to notice, my unit here, this is the unit of the y value. The y value was number of pennies, and this is the unit of the x value. So this is 13.3 pennies over centimeters, or pennies per centimeter. Two more things we need to think about. The y-intercept of a trend line is often drawn from the origin. So it often goes through the 0 value down here, okay? But that is not always true. So I'm just going to say, but not always. You should consider if the experiment allows for a 0 value of the independent variable to create a non-zero value of the dependent variable. So in the case of the Spaghetti Bridges lab, 0 on the x-axis, 0 spaghetti, cannot create a 0, can only create 0 pennies. You can't hold pennies with 0 spaghetti. It just doesn't make sense. So you have to go through the origin. Whereas in the case of this experiment that I'm drawing over here, so here I have the dependent variable being the length of this spring, and the independent variable is the mass. Well, if I had a mass of 0 grams, I probably still have some length to my spring. It's probably about in this case, it's a 6 centimeter spring, even if you don't hang any weight on it. And so it actually makes sense that the y-intercept would not be at 0. In this case, the y-intercept shows the spring's length with 0 mass. Okay? Once again, most physics experiments are going to have a y-intercept of 0, but not all of them. And it is very important to think about whether your y-intercept should be 0 or not, and what does that mean.